We present daedalus, a CAD plugin for designers to generate blind and low vision accessible aids paired with laser cut components. Daedalus remains accessibility aware throughout the editing stage by implementing constraints on component position and symmetrical editing. Assembling users can follow the tactile aids generated by daedalus, such as entry component, tactile arrows, assembly order based on proximity, and symmetrical arrangement. With daedalus, users can perform more accurately on laser cut assembly tasks. Laser cut assembly is a task that usually relies heavily on vision, including actions such as distinguishing the matched edges which form a joint, finding symmetry, or observing the nuances of different joint profiles. Such actions are less accessible to people with blindness or low vision, who usually rely on the sense of touch for such manual tasks. To address these issues, we conducted a formative study with blind and low vision participants, where we introduced basic joint types such as finger, slot, and mortise and tenon joints by presenting 5 chair models. We found that blind and low vision users experienced difficulty in finding the first component to assemble, as well as finding which parts of individual components to join. Assembly order was also an issue, often requiring participants to deconstruct and reconstruct parts of mid-assembled models. Without vision, it was also difficult to identify and stabilize parts of mid-assembled models during the assembly task. Based on these findings, we developed daedalus, a design tool that can generate accessible tactile aids to be laser cut along with Fusion 360 assemblies. The user can import sketches of a laser cut model and create an assembly with the joint assembly function in Fusion 360. They can choose whether to add support for stabilizing the laser cut model. Daedalus will then automatically capture the footprint of the laser cut model and provide the support area for it. The user can click Generate Layout and select an entry component provided by daedalus. Entry component suggestions and ordering were determined based on the design heuristics distilled from our formative study. The user can further edit the generated layout to arrange laser cut components within the printable area of the board. Daedalus remains accessibility aware throughout the editing stage. For example, the movable range of a component is constrained to maintain the layered assembly order. Symmetrical components will also remain mirrored during editing. Given these inputs from the user, daedalus can finally generate a colored SVG file that includes both tactile aids and laser cut components ready to print for laser cutting. The blind or low vision user can find the entry component through a hollowed circle on the bottom right of the plate. Next, the user can follow the tactile arrows to find the subsequent components and assemble them. The mid-assembled model can be placed into the ground support to enhance stability. The user then follows the arrows to find the next component and joints to assemble. With the ground support, the user can easily assemble the components. The assembly order is specified based on components' proximity to the user. If the user loses track of the tactile hints, they can put the model back into the plate to re-access those tactile hints. The layout is also arranged symmetrically, which allows the user to find components more easily. And finally, complete assembling the laser cut. For more information, please refer to our paper.